With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question is saying this: the major product in the following reaction is, right? So we have to find out the major product Y, right? So that means we have to find out this Y, right? So here's a series of reaction, right? So this reactant is reacted with HgSO4, H2SO4 and water, right? So after this X product is formed, right? When this X product is treated with C2H5 MgBr, that is Grignard reagent, right? So in the presence of concentrated H2SO4, there is a formation of product Y, right? So we have to find out this Y product, right? So let's start it, right? So we have a alkyne, right? So we have alkyne system, right? So you can see here, this is our alkyne system, right? So these are CH3 group, 2 CH3 group, right? And at this position you can see here, this is connected with C triple bond C, right? So this is connected with C triple bond CH, right? So you can see here, this is C triple bond CH, right? And this is also H, 1 2 3, and this becomes 4, right? So there are 4 valency of carbon, right? So now you can see this is our reactant, right? So now it is treated with HgSO4, right? So HgSO4, right? And H2SO4, right? H2SO4, right? And H2O, right? And H2O, right? So now you can see here, actually this water molecule is acting as a nucleophile over here, right? So now you can see there are plus I effect of these two methyl group, right? So due to this bond shift here, right? So you can see here, there is electrophilic character over here and there is nucleophilic character over here, right? So now you can see here, this lone pair, right? So the lone pair of this oxygen will attack on this carbon, right? Will attack on this carbon, and there is a reaction proceed like this, right? So you can see here, this is CH3, right? And this is also CH3, right? So this is CH3, right? And this is H, right? And it becomes C, right? And here double bond, right? Here double bond, and this becomes OH2 positive, right? So I can write like this, right? So OH2, right? So this is water molecule, right? Here, and since it gives its lone pair, right? So that means it acquires positive charge over here, right? And it becomes, you can see here, there becomes a negative charge over here, so it will attack on this HgSO4, right? So you can write here like this, right? So CH, right? And HgSO4, right? So you can say like this, right? So HgOS double bond O, right? So double bond O negative, right? This is O negative, right? So this is O negative, and here it is double bond, right? So this is our, you can say this, the reaction proceed like this, right? So now you can see here, in the next step, this proton, right? So this proton will release, right? So that this proton will release, and there's a formation of OH, right? So this proton will release and there's a formation of OH. You can see here, now the reaction will be look like this. This is CH3 over here, and this is our hydrogen, right? So and this is our OH here, and this becomes double bond here, right? And this is our C, right? So you can like this, you can write like this, CH, and this is HgOS double bond O and O negative, right? So double bond O and O negative, right? So now you can see here, this is our product, right? This is not our product, right? So now the reaction proceed further, right? So the reaction proceed further, right? So since you know that here there's a removal of minus H positive, that means there's a removal of proton, right? So you can denote like this, minus H positive, right? So now you can say mercury is a metal, right? So mercury is a metal, right? So and this, due to this, carbon acquires negative charge over here and it acquires positive charge over here, right? That means you can see here, this proton will attach at this carbon, right? So this proton will attach at this carbon and this will release, right? So in the next step, you can see here, the next step will become like this, right? So this is CH3 and CH3, right? And here it is hydrogen, right? So it is connected with COH, right? And it becomes double bond CH2, right? So double bond CH2, actually it is our X product, right? So this is our X product, right? So now you can see this is actually a Markovnikov addition, right? So that means negative part goes to that part where there is a less number of carbon, right? So where there is a less number of hydrogen, right? So it is actually a Markovnikov addition, right? So now this is our X product, right? But we have to find out the Y product, right? So we have to find out Y product, right? So further this X product is treated with Grignard reagent, right? Further this X product is treated with Grignard reagent, right? So now you can say this is actually an enol system, and we know that enol system is very less stable, so it will be tautomerized, right? So that means there is a formation of keto form, right? So this is enol form, so there is a formation of keto form, right? So you can write like this, right? So you can write like this, that becomes CH3 over here and CH3 over here, right? And here this is hydrogen here, and this becomes C double bond O, and this is CH3, right? So this is keto form, right? So this is keto form, right? So now you can see here, this is our X product, right? So this is our X product, right? So you may write this like this. This is not our X product, right? So this is actually enol form, right? So since enol form is less stable, so it will form a keto form, right? So it will convert into a keto form, right? And after this is treated with Grignard reagent, right? So this is treated with Grignard reagent, right? So in the Grignard reagent we have used C2H5 MgBr, right? So that means we have used this C2H5 MgBr, right? So that means in the first step we have used C2H5 MgBr, right? That means C2H5 MgBr, right? So this is our Grignard reagent, right? And in the presence of, right, so we cannot use over here water, right? So Grignard reagent is very reactive, right? So here you can see here this Grignard reagent, we cannot use water with Grignard reagent, right? So we have to use water in the next step, right? So that means you can see here in the next step you have to use water, right? So you have to use water, right? So in the next step you have to use water, right? Right, because if you use water with Grignard reagent, so it will react with this water and there is a formation of ethane, right? So that means Grignard reagent will vanish, or you can say will destroy, right? So in the third step, right? So in the third step you can see here it is reaction is carried out in the presence of constant H2SO4, and the reaction condition is heating, right? So reaction condition is heating. That means in the third step you can see here there is a concentrated H2SO4, right? So there is a concentrated H2SO4 and reaction condition is heating. That means we have heat the reaction, right? So now you can see here in the first step this is Grignard reagent, right? So that means this becomes negative charge over here and this becomes positive charge over here, right? So this will act as a nucleophile, and due to this electronegativity of oxygen, so this part becomes partial negative and this part becomes partial positive, right? So this becomes electrophilic reactor, right? So now you can see here, so the reaction will be look like this. Nucleophilic part will attack over here, right? So will attack over here, and there's a formation of this species, right? So you can see here this is the species like this, that is CH3 over here, and that is CH3 over here, and this is our hydrogen, right? So now you can see here this becomes C2H5, right? So C2H5 will attach over here and this becomes O negative, right? So O negative, right? And since it is positive, so it will attach here, right? So it will attach here just to stabilize this oxygen, right? And in this is CH3, right? So this is our CH3, right? So now we have used water, right? Just to work up, right? So that means we have used water. So you can see here we have used water. So that means the negative part, right? So the negative part, right? So that negative part, that means water, right? So H positive ions will come from this water, so it will abstract this proton, and there is a formation of this species like this, right? So you can see here this is CH3 and this is CH3, right? And there is a hydrogen over here, and this is C2H5, right? So this is C2H5, right? And this becomes OH, and this is CH3, right? Now in the reaction condition we have used concentrated H2SO4 and heating condition, right? So that means this OH negative, right? So this OH becomes protonated. That means the lone pair of this oxygen, right? So the lone pair of this oxygen will abstract the proton, right? So will abstract the proton, right? So you can see here the lone pair of this oxygen will abstract the proton, right? So from this proton will be come out from H2SO4, right? So H2SO4 that we have used in the reaction condition, right? So we have used in the reaction condition, and that H2SO4 is concentrated H2SO4, right? So you can see here that is concentrated H2SO4, right? Concentrated H2SO4, right? So this proton will be that means the lone pair of this oxygen will abstract this proton, and that means this becomes protonated, right? So that means you can see here this here CH3, here CH3, right? And this is H, and this becomes, you can see here this becomes C2H5, right? So C2H5, right? So this is C2H5 ethyl group over here, and this is CH3, and this becomes OH2 positive, right? OH2 positive, right? So now it becomes a very good leaving group, right? So it becomes a very good leaving group, and we have hit the reaction. That means we have increased the temperature, right? So we have increased the temperature, right? So that means this leaving group will leave, right? So this leaving group will leave, right? So I can write the reaction like this, right? So I can write the reaction like this. This leaving group will leave, and there is a formation of tertiary carbocation, right? So there is a formation of tertiary carbocation, right? So this is CH3 over here, and there is a CH3 over here, and this is H, right? So, and this there is a formation of C2H5 tertiary carbocation, right? So this is tertiary carbocation, right? So there is a CH3 over here, right? And this becomes tertiary carbocation, right? So now, since to stabilize this to proceed reaction, so this proton will leave here, right? So, and there's a formation of alkene, most substituted alkene, right? So that you can see here, this is CH3 over here, and this is CH3 over here, double bond, right? And this C2H5, right? So this is C2H5, right? So this is C2H5, and this is CH3, right? So now you can see here, this H2SO4 acting as a catalyst. It is just speeding up the reaction, right? So, and we are getting here over here, alkene system, and the most substituted alkene, right? That means we are getting at most of it, because these are all R group, right? So these are all R group, right? So now let's check our options, right? So let's check our option, right? So options are, you can see here, in option A, right? So in option A, that means the alkene is not substituted, right? There are 2 hydrogen, right? So that means this cannot be our answer, right? So this cannot be our answer, right? And in option B, you can see here, this alkene is also not substituted, because there is 1 hydrogen over here, and you can see here, this is substituted, right? So that means this is not our answer, because we know that in our alkene, all the carbon, that means all the groups are R group, right? That means all the groups are R group, right? So that means our alkene is most substituted, right? So that means this cannot be our answer, right? So now you can see here, this alkene is substituted, most substituted. That you can, there's 2 methyl group over here, and this is ethyl group, and this is methyl group. That means this is our answer, right? So that means this is our answer, right? And if you talk about option D, so you can see here, this is not substituted, because there are 2 hydrogen over here, right? And so D cannot be our answer, right? So now we are left with the correct answer, that is option C, and this will be the correct answer, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.